So, hello everyone, welcome to my presentation. Very happy to be here again. Our today's topic is behind closed doors, hacking RFID readers. But before we actually go to hacking stuff and doing all those fancy things, a little reminder. So sometimes there are many easier ways to get inside somewhere than hacking RFID stuff, and this is an example of that. So here, on this video, you see me with this strange device. It's made out of wire, and it looks a little bit like a fishing rod. And this is exactly what I'm trying to do. I'm trying to catch the handle with this device. It needs a little precision, but in a few seconds, if everything works great, OK, I'm almost there. I almost have the handle. Just, a little bit of motion here. Yeah, emotions. And like that, I managed to open the door without actually scanning the cards. So yeah, this is one way of getting inside. I actually have this device here with me. So yeah, I try to catch some of you on the audience. So if you're interested, you can catch me after the presentation. I will show you this. And who am I, actually? Well, my name is Julia Zduńczyk, and I work as an IT security specialist at Securin in Krakow, Poland, where I perform penetration tests and red team assessments. But really what I love doing, besides finding strange new hobbies, is getting adrenaline rush, and either by training horseback archery or by breaking into different server rooms, which my job luckily allows me to do. And I also presented during last SecTi, as it was mentioned. By the way, who saw my last presentation? Hands up. OK, so there is many of you. Nice to see you all here again. And last year, I talked about attacks on access cards, actually access cards cloning. And the thing with this is that sometimes it works. For example, when there are low security systems that you see here on these slides, for example, prox card. And if the employees don't take care of their cards, and it is easy to go, for example, on this picture, behind someone and clone their cards. But sometimes it does not work. If the systems are configured well, for example, this may be a COS system or a Desfire, good configured Desfire system, we won't be able to clone the card. Then we have to look for another ways. And we may try to look for situations like on the picture when the card is permanently attached to the reader. It's very convenient, I'm sure, for the employees. Yeah, I was very surprised when I saw this. But sometimes we won't be so lucky. And this got me thinking, what are the other ways that we could bypass access control systems to get inside without card cloning? And this presentation will focus on attacks on RFID readers. And before we start, I want to divide those access control systems into two main fields. First will be systems that use autonomous RFID locks. And how this looks like. Well, we have a door. That's a barrier between an insecure area and secure area somewhere else. Next to the door, we have a reader, obviously. And this reader communicates with access tags via radio frequency. The tag sends its UID to the reader. And in case of these autonomous RFID readers, the reader has a memory with UIDs that are valid to open the door. And it itself makes the decision if it will open the door or not. So everything happens inside the reader. And what are the problems with this? Well, before we go to the problems, I will show you how exactly these readers work. So we can add the cards that are valid to this reader in two ways. One is using special manager add cards and delete cards that will add the card. And the second one is administrator setting. And yeah, let's take a look at that. Yeah. Do you see my screen or not? Well, I know what happened, so you should see it in a moment. Now you see my screen. Well, here I have an RFID reader, and I have some cards. Now, look here. This will light up green when the card opens the door. So I can put this card close to the reader, and I can delete it from the memory. This is a manager delete card. So let's put it close to the reader. It's in the administrator mode. Put this card close to the reader again. And put the delete card again. And now, it no longer lights up. It no longer opens the door. So that's pretty easy, but I already see some problems with these systems. First one, as you can see here in the red rectangle, there is some default factory code for these readers. And obviously, some of the readers may be left with this default factory code, so always check the documentation. It will be mostly 6x8 or 6x9 or something like that. Also, these manager add cards and delete cards are simple MIFARE cards. And if you saw my presentation last year, you will know that the MIFARE cards are mostly easy to clone. So we could just clone this card and add our cards to the system. But there are more interesting problems as well. First would be the logic bypass of the lock operation. And by that, I mean a card that would always open the lock, even if you try to delete it. And this is actually my question for you. Do you have any ideas? Which UID would be the one to always open the lock? Here is a little reminder how these IDs look. So they are hexadecimal. In case of this log, these are MIFARE cards with 4-byte IDs. And now, I listen to your propositions. Zeros, all zeros, OK. We can try that. I have a prox mark with me here that will allow me to put the ID on the card. So yeah, set the ID to all zeros. Will it work? It doesn't work. OK, another ideas? All Fs, who said that? Yeah, there were 2 people here. OK, so actually, you can try to set the ID of all Fs, so the biggest number in the system. Let's see if it works now. As you can see, it opens the lock. But, yeah. So it was a great intuition. And now you may say that I already added this card before. So let's try to delete it. We'll get into the administrator setting. Now we are in the administrator setting. I will use 2 to get into the deleting mode. I deleted this card, accept, and now use it again. It still opens the lock. We cannot delete this card. It will always open the lock. Yeah. And why this happens? Honestly, I'm not sure. Maybe it's a problem with the software. If someone of you knows or has access to the software, you may show me. But it's very interesting, and it works on another locks as well. OK, so another problem that may happen is using something called electromagnetic field generator. And I will try to show you how this works now as well. Let's switch back to the camera. So here I have a light bulb to show you how this generator works. Here, I have this generator. It looks like this. And it basically generates a very strong electromagnetic field that lasts a few seconds. And I can try to turn on this light bulb with it. So it's a pretty strong electromagnetic field. And we can try this on one of these readers. I will connect another one. Oh, so this is this reader here. Oh, there is a lot of light, so I'm not sure if you will see the... Do you see? Oh, why is it so white? OK. Do you see what's happening? Here is the light. OK, it worked on my microphone, but not on this reader. And there is a reason for that. Here I show you a demo of this attack. Here is a Saberi lock. First, I put a non-working card to it, and then I put the electromagnetic field generators, and it opens the lock. And the problem with that is that not very reliable. Sometimes it will open the lock, sometimes not. Sometimes it will fry the lock, and it will no longer work. And this is what happened with my lock. So yeah, this is why I'm showing you this video. Yeah. And this is another problem. But what else can go wrong with those autonomous readers? Well, if you are desperate enough, you will find a way. And there are many more problems. For example, I heard the stories that you can put a magnet close to this reader, and it will open because it has some electromagnetic relay inside. You can try many different ways with them. So in most cases, they are not very secure. And these autonomous readers are mostly used in places like apartment buildings or low security areas. And if we go to the actual facilities or advanced organizations, we will meet another way that the access systems are used. And in this case, we will have a door as well. That is a barrier between insecure and secure areas. And next to the door, we have a reader. The reader communicates with a card over radio frequency, so it's all the same. But in this case, the reader does not have a memory of the valid cards, and it does not decide which cards are valid. It simply sends the UID further to the controller. It's sent over the wires. And the controller is the whole heart of the operation, and it will decide on the door, and it will send the commands to open or close the door. And in the later part of the presentation, we will focus on this red arrow there, so the communication between the reader and the controller, because sometimes it's not very secure, and we can try to exploit it. So the most common protocol used between the reader and the controller, it's called Wiegand. And it's very, very simple protocol. So basically, it will look like this. The reader will have two wires on the back. One will be white, one will be green, and they will be used to send data. The white wire will send 1 bits, the green wire will send 0 bits. So far, everything's simple, but the problem with Wiegand is that sends the UIDs in the plain text form, and there is no encryption at all. And I want you to understand that. We can have very secure systems between the cards and the reader. For example, CEO's card. So the communication between the card and the reader will be encrypted. We won't be able to clone the card. We won't be able to sniff the communication to obtain the ID of the card. But in the moment the reader gets this UID, unencrypts it, it throws all the security out the window and sends this UID further unencrypted over the Wiegand wires. And it makes it possible to actually sniff the communication. And, well, let's see how this may look in real life. So now I will change my setup a little bit for this demo. And let's switch to the camera. OK, so here is my access control system setup. So what we see here is this RFID reader, this lock that holds the door, and on the other side of the setup, there is a controller, a lot of tape. I know it's not that beautiful on the other side, but here we have a controller. It's basically a Raspberry Pi with some Python code running. And I know this looks a little bit uneven, maybe, and it looks like it's held by a few pieces of tape and a sheer willpower. But I did my best. I made it 2 days ago, especially for you guys here today. So I hope you will like it. OK, and now let's see how this looks. This reader works with CEO's cards. So as you see, it now opened the door. And I want your cooperation with this demo. So how will we try to sniff the communication? We will use a device called ESP key. It's a very small, as you can see. And we'll have to put it on the wires behind the reader. So the first step would be getting the reader off the wall. So now we will go through this together. Who wants me to get the reader off the wall? Hands up. Yeah, we'll go with the demo. There is a few of you, so yeah, let's do this. Normally, there would be a screw here, but I left it so it will be a little bit faster. Oh, do you see this beep? Yeah, we have a problem. It was an alarm. We can't just simply go and take this reader off the wall. The alarm is here. It's this sensor right here. So let's try to disarm this alarm now. In this case, it's very simple. It's just those two wires connected together. When I get them apart, the alarm no longer turns on. And OK, so we got caught. But I managed to disarm the alarm, so maybe no one heard this beeping. So let's go and try to install this ESP key. So now we get the wires. As I told you, the Wiegand wires, the white one and the green one, and the power wires. And now I will use this punch-down tool to put the wires into the connector. We don't have to cut the wires. We can just punch them down. Do you see what's happening? I hope so. OK, so first, the white wire. It went in a little bit too much. Second, the green wire. The green wire is for zeros in Wiegand communication. OK, went in. Now, the ground in the third connector. OK, it should be in, I hope. And the power, the last cable. And let's see what happens now. OK, so I don't know if you're able to see this, but there is a little LED on the ESP key. And it means it actually boot up. So we can check that now. And connect to the Wi-Fi network that the ESP key device put on. And let's go to the ESP key page. So here we see the page of our ESP key. We can check the diagnostics if everything was connected well. And I can already see that it was, because here you see this little green line on the top and the little white line on the top. It means that it has the access to the Wiegand wires. So what we will do now, we'll put this back into the wall. As we would do during the red team assessment, so that no one knows it happened. I still have connection to the ESP key, great. And now we will try to get some data, actually. So let's say we managed to do all this, and someone comes and scans their card. So it was a mock of an employee coming up and scanning the card. And we actually got the ID of the card. It is here. And what we can do now, we have the ESP key on the wires. We can take this ID and replay it. So now, without using a card, watch closely. I will transmit this ID. And it opened the door. So as you can see, it's pretty simple right now. So now we have access to this door. We can actually open it whenever we want. But what is the problem with the situation? We only have ESP key on this one reader. So now we only can open one door in the facility. It's not very useful for us. And this is a CO's card. So even though we have this UID, we cannot make a clone of CO's card. And why does this happen? Let's see it here. OK, so first, a little more information. This reader actually does not only use CO's card. It is also configured to use another card that's called prox card. And now the differences between those two. Prox card is an unsecure card. It operates on low frequency. And it has an encrypted ID. And it sends its ID to the reader. It's very easy to clone. When we actually try to read it with Proxmark, it will show its UID right away to us, and we can clone it, we can use it around. The CO's card, on the other hand, we don't know ways to clone this card because the real ID of the card is encrypted inside. And when we try to read it with a Proxmark, for example, it will send us some random data, so it won't be helpful. And because this real ID is encrypted inside the card, we cannot simply make a CO's clone out of this ID we got with the Wiegand wires. But what we could do in this case, we could run the downgrade attack. And the idea is that because there are two cards enabled, and as you saw, the Wiegand wires only send the ID of the card, no information what type of card it is. So we could actually take this plain text ID of the COs that we got with ESP key and write it to the prox card. And then we'll have a prox card with CO's ID, but a controller will not know that, because what's sent over the Wiegand wires is the ID. And OK, so let's try to do this. So here I got the ID of the CO's card. And here I will go one away, once again, to my Proxmark. And I put it on camera. So here I have some prox card. And let's try to write this CO's ID here. There is another additional step on the way. I know it's a little bit complicated. But we cannot just simply write this ID we got here to the card, because the prox card format also uses a preamble. So to write it down so it will work, we need to add this preamble that we see here. So we'll now take the ID of the card, and this preamble translates it to 2006. So we need to add 2006 to the start of the card. OK, so let's try to put it on the prox card. OK, and if everything worked great, we now managed to open the door with a Proxmart. And the reader thinks, the controller thinks, it was a CO's card. So why is it better for us as a red teamers? Well, as I told you, with ESP on the wires, we can only open this one reader. But now I have a clone. Actually, it's not a clone of the CO's card, but something that for the controller will look like the clone of CO's card. So we can go around the building and try to open another readers with that. OK, and a little mention about those tamper mechanism, about this alarm that we got caught. So there are different ways that this tamper can be working. For example, this optical sensor that was here, there may be a metal spring or a metal part that will touch the backplate of the reader, and it will see if it disconnected from the backplate when we took the reader off. And the problem with those is that they simply send the information that there was a tamper attempt detected via one of the wires. And these wires are obviously not often connected, because why would we care to connect those wires and worry about tamper tries? Another problem is if they are connected, they may be connected and send information to some logs that no one ever checks. And another thing, they may make the reader beep, which happened here. But if there is no one around, we can simply disarm this alarm and continue with installing the ESP key. And everything cool so far. We managed to put the ESP key here, and it was very easy because there was no security guards around me here. But during a real red team scenario, there will be people in the building. And how can we actually go inside, get close to the reader, take it off the wall, install the ESP key, took it back again without anyone noticing, right? So obviously, we could try social engineering. I'm sure many of you heard stories that you can get everywhere with a ladder. And actually, you would be surprised, because sometimes it may work. So this is me in this very, very professional disguise as a server room technician. And actually, I managed to get away with it and go through one reception. So yeah, it was very successful. But, well, in the end, to be honest, I got caught. It was partly because of these guys, partly because of other reasons, but there is a very long story for another day. But yeah, it worked for a moment. But in most cases, we don't really need to do so complicated things, prepare a disguise. What we can do is we can just act very confident. And in this video, I'm trying to open a server room with a plastic card. It's called door shimming or door latching technique. And yeah, I managed to open the server door room. And what's the clue of this? Well, this happened in the broad daylight with people walking in the corridor in the office. And they didn't know that there was red team happening. So because I was smiling, because I was acting very confident, I was talking to my friend next to me, we were laughing. The people walked around, they looked at me, maybe they smiled awkwardly, but no one actually asked me what I'm doing. No one went to gather the security guards, so we get away with it. And in facilities, in organizations like this, if you act very confident, you may get away with many things, even when other people are watching you. And OK, so we talked about Wiegand. And as you can see, the Wiegand protocol is not very secure. It sends the ID unencrypted, and it's a very, very old standard. And obviously, we have some better things right now. And now, there is an OSDP protocol, Open Supervised Device Protocol, that is used more widely every day. Sadly, not in all facilities so far, and still most of the organizations use Wiegand. But there are many more readers now that use OSDP. Why is it better? Well, it supports AS encryption, so that's for first. It's bidirectional, so the reader can communicate with the controller, but the controller can send commands to the reader or try to detect if there was any device on the wires. But there are also some problems with OSDP protocol. First one is that supports AS encryption, but it does not require it. And in default mode, it works without encryption, so you actually have to turn the secure mode on. There are also other problems. Here, on the bottom of the slide, you see something called Melon device. It's basically an older brother of the ESP key. It was created by guys from Bishop Fox. And it can sniff the communication of OSDP when it is in this not secure mode. It can also try to run other attacks, because in some configurations of the OSDP, you can actually send a command from the reader to the controller that you don't want to use encryption, that it will turn off their encryption for you if it is configured this way. So you can use this device for that. There are also some other attacks. Sadly, we don't have time today to go very much in depth. But if you're interested in that, you can drop me a message on LinkedIn, and I will send you resources. And yes, the OSDP, I think, if it's configured well, is the best solution for today with the most common readers. For example, HID signal readers use OSDP only, no Wiegand at all. So if we configure it well, we should be safe. And now, another additional demo for the end of this presentation. So another thing that we could do is to try denial of service on the reader. And maybe it doesn't sound this unsecure as the previous attack, but we can make this useful if we want. And now, how this looks. This HID reader that I have here with me has a Bluetooth module. And we can connect to this reader via HID Reader Manager app. And we can try to locate this reader and try to inspect it. And now, let's see this. So here's the reader. I will take my app. OK, and now I see this reader on my app. And I will turn the locate mode on. It lights up, and it beeps for about 8 seconds. And in this time, there are no cards accepted. We could not authenticate to this reader. Another thing I can do is to put the inspect mode. And in inspect mode, in lights up, it does not beep. But it also doesn't accept any cards in this mode. So how could I use that, actually? Well, let's imagine that we are in a red team scenario. And we managed to get inside a server room, let's say, that's protected by this reader. And we are doing some things inside. We don't want someone to walk on us and see us there. So while we're inside, we can put this in a continuous inspect mode. So it will light up. It will not accept card. It won't beep. So hopefully, it won't bring attention. We can hack stuff in the server room or try to do different shady things, and then get out when we are ready, stop the denial of service mode. Another thing we could try to do is to use it as a decoy. So let's say we want to do some shady things in one part of the office. We can put readers in other part of the office into the denial of service mode with beeping, and hopefully, it will focus the attention of the people on this reader. Another problem that may happen with this HID Reader Manager app is that actually, when we get into this inspect mode, it will give us access to the configuration of the reader if it's not configured that it needs authorization. It may sometimes happen. And if it happens that it does not need authorization, we can use this application to change configuration of the reader. For example, switch from OSDP to Wiegand protocol, or put some other credentials working, the less secure ones. And yes, now these were the attacks I wanted to show you today. And now I would like us to together think about different ways that we could secure ourselves against these attacks, what we can do, what should be the guideline for someone installing this system for it to be secure. I'm waiting for you guys, for your answers. Maybe you will give me some new ideas. Can someone repeat this to me so I will hear? Authentication requiring a code. Two-factor, you mean PIN code. Yeah, that's a good idea. So, well, it's a good idea, but I have to tell you something. The Wiegand protocol, actually, if we have a reader with a PIN code, the PIN code will be sent to the controller over the Wiegand protocol. So in this case, we will get both the ID of the card and the PIN code as well. So yeah, in case of attacks on Wiegand, it won't work. But in case of other attacks, two-factor authentication is always a good idea. Other ideas? Active parts? Can someone repeat that it's closer and heard it? Active cards. Changing data on the cards. OK, so you mean that we switch the IDs of the cards? Yeah, if we actually recognize that someone tampered with the system. And there is also another problem with this ESP key, because if we get it off the cables, it leaves the insulation broken a little bit. So if we are administrator in the building, we can take the reader off the wall, and if we see that there are some cuts on the insulation of the cables, we will know that maybe someone installed the ESP key. And this is a good idea to switch the cards and their UIDs. OK, but basically, to summarize this presentation, we should always place the access controller on the secure side, because in the first example, well, there wasn't a controller, but the reader, we may say that the reader acted as a controller. You remember, with those autonomous RFID locks. And it was bad because we had access to this reader, and we could take it off the wall. We could use the electromagnetic pulse generator on it. So we should always place the controller in some secure place. Another thing, always use the more advanced solution. So don't use Wiegand, use OSDP if you can. And also remember to configure the OSDP well, so that it will be encrypted, for example. Proper tamper detection, so that there is some alarm that turns on when we get the reader off the wall. The alarm does not go to some logs that someone never checks, but actually prompt some action from the security guards, in example, in the exact moment that the alarm happened. Also, ensure that there is a secure access via HID reader manager, so that we can know actually DOS the reader, or that we cannot change the configuration of the reader. And also many other things, as always. As I showed you at the start, we can always try different ways to get inside. So always look at your access control systems as a whole. Check if there are no gaps between the door. Check if you cannot just actually shim this lock to open it very easily with a card, for example. And check all you can, use secure cards. And yeah, so that would be all from me over the attacks. Thanks to everyone who helped me preparing this presentation and this very advanced setup here. And yeah, so if you have any questions regarding access control systems and you want to know more, you can follow me on LinkedIn. I will probably put some articles in the following weeks. Maybe not the closest weeks, because I plan to play Baldur's Gate after this presentation. But after I end it, I will write some articles. And you can check our website if you're interested in red team assessments. So thank you very much, and I'm waiting for your questions.
Thank you so much, Julia. Like I said, I don't know if we have any time for questions. I think maybe one or two, and Are there readers that will like brick themselves instead of having an alarm, just completely like die?
Oh, so they will die when the alarm happens? Well, I guess we could configure it its way, but I've never saw that because availability is also important in those systems.
All right.
But it might be an idea, actually.
All right, we're going to take you downstairs and interview you, but like I said, thank you very much, Julia Zduńczyk. I keep butchering your name, sorry.